So our first question is, what data are represented by the stem and leaf plot below? So we're going to look at this. When you have a stem and leaf, the stem is the tens place. So this 4 is actually 40, and this 0 is the ones place. So that would be 40, then 42, then 45, 46, 47, whoops, there we go, and 49. Then the next row, the 5 is in the tens place, so we'd have 50, and then the leaf is the ones place, so 51, 55, 58, 59, and 59. Then we have 62, 63, 65, and 68. So that is our data that's represented by that stem and leaf plot. So we're going to find the mode and the median of the data. So the mode is the one you see the most. Mode is most. And the median is the middle. Think of the median of a road is the middle of the road. So the mode is the most. So I'm going to look in the 40 where the stem is the 4. And look at the leaf. I don't see any repeats. So then I go to the stem of 5, and I do see a repeat here. I don't see any in the 6. So the mode is 59. Now I'm going to look at the median. Now they're all already in order because they're in the stem and leaf plot. So the median is that middle number. So I'm going to count, and I'm going to say, okay, how many total numbers do I have? I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So 15, the middle number is number 8. So I'm going to count 1, 2, 3, 4, 5, 6, 7, 8. So the median is that middle number. That means there are 7 on each side, is 55. Because there's 1, 2, 3, 4, 5, 6, 7 numbers after it and 7 numbers before it. Okay, what situation could this represent? You've got 12, 13, 21, 27, 33, 34, 35, 37, 40, 40, and 41. An example might be maybe the ages of something. The ages of people playing on a co-ed softball team. It could be the different or the difference in people's weights. It could be all kinds of things. But think about what these numbers could represent, and that'll help you decide what kind of choices you have. Just make sure that you can write them out as numbers, and that'll help you decide which one fits the best. Make a histogram involving or using the data from the table. So between 10 and 19, how many numbers do I have? I have 1, 2. So I'm going to draw my line up to 2. Color it in. Then how many do I have between 20 and 29? Well, that's going to be 1, 2. How many do I have between 30 and 39? 1, 2, 3, 4. And then last, 40 to 49, I do have 1, 2, 3 numbers. So I'm going to draw a column up to 3. And that is how we're going to make this histogram. Okay, in a recent survey of middle school students about pizza toppings, it was found that 21 students like pepperoni, 29 like banana peppers, and 12 like both. If 70 students were surveyed, how many students did not like banana peppers on their pizza? So if there were 70 students, 21 of them liked pepperoni, 29 liked banana peppers, and 12 liked both. We've got 21 plus 29 plus 12. That'd be 11, 12, 62. We're missing some kids, so that would be 8 of them don't like either of those. So how many students do not like banana peppers? So I'd say the 8 that are neither, and the 21 that are just pepperoni. So that would be 29 students do not like banana peppers. Okay, which is the best measure of central tendency for the type of data below? The mean, median, or mode? So hours of screen time each night. Well, for this one, some people may have 0. Some may have 1. Some may have 6. Some may have 5. Okay, on this one, the outliers are limited because it's a small number. So I would look at the mean. Really look at the reasoning over here. Those outliers are numbers that just don't fit in with the rest of the data. "30 girls and 35 boys participated in an intramural bowling league. The two-sided stem and leaf plot below shows the highest score of each of the participants. What is the difference between the highest score of the girls and the highest score of the boys?" So the boys' highest score would be 128. The girls' highest score would be, remember the 12 is the tens place. So 1, 2, and then we're looking for the highest number over here would be 6. So 126 for the girls. Now we're looking for the difference of these. So the difference would be 128 minus 126, which equals the difference in the score, which is 2. Girls and boys participated in an intramural bowling league. The two-sided stem and leaf plot below shows the highest score of each of the participants. Compare the scores of the girls and the boys using the mean, median of each data set. So we're going to check first. Let's use orange for the girls. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 15. So we're going to add all of these scores up and divide by 15 for the median. So we're going to add up 92, 99, 100, 100, 101, sorry, 101, erase that, 106, 117, 118, 122, 124, 125, 125, 125, 126, and 126. Okay, and then for the boys, we're going to do the same thing. The boys, we're going to add all of theirs up. 105, 108, 109, 110, 111, 111, 117, 123, 127, 127, 128. And we're going to divide it by, there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 of them. Okay. So now, I'm going to add those up real quick. And I get, for the girls, I get 1,581. And we're going to still divide that by 15. When I divide that by 15, I get 105.4. That is the mean of the girls. Now I'm going to do the same thing for the boys. And for the boys, I got 1,276. And we're still going to divide that by 11. And we get the mean is 116. Now we're going to look for the median. The median is the middle. Okay, so half of 11 is 5 1/2, so 6 is in the middle. 1, 2, 3.